Section 1800 Pre-stressing Description The work shall consist of imparting pre-stress to structural concrete members by stressing of wires, strands, tendons, cables with jacks of required capacity and holding them between approximately designed anchorages and fixed internally or externally to the members. General The work shall be carried out in accordance with the drawing and the specifications or as approved by the engineer. Structural concrete and untensioned steel. For the production of pre-stressed concrete members shall conform to the requirements of Section 1700 and Section 1600 respectively of these specification unless especially modified by the requirements set forth in this section. Material All materials shall conform to Section 1000 of the specification. Seating General The seating ducts shall be of the spiral corrugated type either in milled steel or HDP or in PP for internal tendons. They shall be in as long length as practicable from considerations of handling and transportation without getting damaged. External tendons shall be housed in either high-density polyethylene HDPE sheets or metallic steel sheets, plain or with protective coatings which have both internal surfaces. MS seating ducts. The material shall be cold rolled, cold annealed CRNA milled steel conforming to IS 513 intended for mechanical treatment and surface refining but not for paint, hardening or tempering. The material shall be clean and free from rust and normally be bright finished, however, where specified as in case of use in aggressive environment, galvanized or lead coated strips shall be used. The seating shall conform to the requirements specified in Table 1800-1 and Appendix 1800/1. All the joints of seating shall be watertight and conform to provisions contained in Clause 1804.6. Table 1800-1 Details of ducts. Number of strands diameter 6/13. Diameter of duct in mm. Metallic 50 HDP 50. Thickness of MS seating in mm 0.3. Thickness of HDP duct in mm 12/13 75. Metallic HDP 75. Thickness 0.4. Thickness HDP 2.5. 19/13 HDP 85. Metallic 85. Thickness of MS seating 0.4. HDP black 2.5. 27/30. 100 0.5 3.0. 12/15 85 85.4 2.5. And 19/15 100 100.5.3. 27/15 125 130.5 4. Corrugated HDPE sheathing ducts. The material for the ducts shall be high density polyethylene or polypropylene with more than 2% carbon black to provide resistance to ultraviolet degradation. The ducts shall be corrugated on both sides. All tests on raw material and tests to be conducted on the finished product shall be in accordance with the FIV Technical Report Bulletin 7. Corrugated plastic ducts for internal bonded post-tensioning. Each batch of the HDPE ducts supplied to the site shall be accompanied by the supplier certificate for properties of the raw material which shall comply with the technical report bulletin 7. In addition, the shore hardness for D3 section value shall be 60 plus minus 5 for the approval of the finished product. The test mentioned in the appendix A1 to A9 of FIB technical report bulletin 7 shall be conducted at the reputed institutions or at the manufacturer's laboratory. Results shall comply with the provisions of the FIV Technical Report Bulletin 7 except for the wear resistance, minimum bending radius and bond length test which are modified as follows. Wear resistance test. The wear resistance of the duct that is the minimum residual wall thickness after loss shall not be less than 1.5 mm for duct up to 85 mm in diameter and not less than 2 mm or for ducts greater than 85 mm in diameter. Minimum bending resistance. The test apparatus shall be identical to the wear test apparatus with the same clamping force. However, sample shall not be moved but shall be held in position for a period of 7 days. The residual wall thickness shall be as mentioned in A above. Bond length test. The results shall transmit full tendon strength from the tendons to the surrounding concrete over a length of not greater than 40 times duct diameter. Each supply of the duct shall be accompanied by test report of the finished product. Also, the test certificate issued by the institutes will be valid for a period of 2 years. Diameter and thickness of sheathing ducts. The internal diameter and thickness of sheathing ducts shall be as shown in the drawing or as indicated in table 1800-1, whichever is greater. Where pre-stressing tendons are required to be threaded after concreting, the internal diameter of sheathing shall be about 5 mm larger than required above for spans more than 30 meters. In severe environment, cables shall be threaded after concreting. In such cases, a temporary tendon shall be inserted in the sheathing or the sheathing shall be stiffened by other suitable method during concreting. Encourages pre-stressing accessories like jack. Encourages waste block plates etc. shall be procured from authorized manufacturers only. Encourages shall conform to the recommendation for acceptance and applications of pre-stressing system published by FIB. The pre-stressing accessories shall be subjected to an acceptance test prior to their actual use on the work. Test certificates from a laboratory fully equipped to carry out the test shall be furnished to the engineer. Such test certificates shall not be more than 12 months old at the time of making the proposal for adoption of a particular system for the project. No damage encourages shall be used. Steel parts shall be protected from corrosion at all times. Threaded parts shall be protected by greased wrapping and tapped holes shall be protected by suitable plugs until used. The encouraged components shall be kept free from mortar and loose, rust and any other deleterious coatings. Switches of pre-stressing strands and button. Head of pre-stressing wire where provided shall develop a strength of at least 95% of the specific breaking load of the strand or wire as the case may be, where swinging button heading is envisaged. The contractor shall furnish detail of his methodology and contain approval of the engineer prior to taking up the work. Untensioned steel reinforcements around encourages shall conform to the details of the stitching system and as shown on the drawing. Couplers. Couplers of other similar fixtures used in conjunction with the pre-stitching strength or bars shall have an ultimate tensile strength of not less than the strength of the individual strands or bars being joined and shall also meet the requirements of the individual encourages. Testing of pre-stitching steels and encourages. All materials specified for testing shall be furnished free of cost by the contractor and shall be delivered in the time for test to be made well in advance of anticipated time of use. All wire strands or bars to be shipped to the site shall be assigned a lot number and tagged for identification purpose. Encourages assemblies to be shipped shall also be similarly identified. All samples submitted shall be all samples submitted shall be representative of the lot to be furnished, and in the case of wire of or strands shall be taken from the same master roll. The contractor shall furnish samples of at least 5 meter length selected from each lot for testing, along to encourage assemblies complete with distribution plates of each size or type to be used shall be furnished along with a short length of strands as required. Workmanship. Cleaning. Tendons shall be free from loose, rust, oil, grease, tar, paint, mud, or any other deleterious substances. Cleaning of the steel may be carried out by immersing in suitable solvent solution, wire pressing, or passing through a pressure box containing carbonundum powder. However, the tendon shall not be brought to a polished condition. Straightening. High tensile steel wires and strands shall be supplied in coils of sufficient large diameter such that tendons shall retain their physical properties and the end shall be straight as they unwind after from the coil. Tendons of any type that are damaged, kinked, or bent shall not be used. The The packing of pre-stressing wire strands shall be removed only just prior to forming of cables for placement. Suitable strands shall be provided to facilitate uncoiling of wires strands without damage to steel. Care shall be taken to avoid the possibility of steel coming into contact with the ground. Positioning, post-tensioning. Pre-stressing tendons shall be accurately located and maintained in position both vertically and horizontally. As per drawings, tendons shall be so arranged that they have a smooth profile without sudden bends or kinks. The location of pre-stressed cable shall be such as to facilitate easy placement and vibration of concrete in between the tendons. High capacity tendon shall be used to reduce the number of cables thereby eliminating the necessity of grouping. The selected profile of the tendon shall be such that their anchorages are not located in the top deck surface, where two or more rows of cables have to be used. The cables shall be vertically in the line to enable easy flow of concrete. The clear vertical and horizontal distance between any two cable ducts shall in no case be less than 50 mm or diameter of duct, whichever is greater when grouping of cable is not involved. Where precast segments are used, the clear distance between cables shall be at least 150 mm. Seating shall be placed in correct position and profile by providing suitable ladders and spacers. Such ladders may be provided at interval of approximately 1 meter. Seating shall be tied rigidly with such ladders spacers bars so that they do not get disturbed during concreting. The method of supporting and fixing shall be such that profile of cables is not disturbed during vibration by pressure of wet concrete by workmen or by construction traffic. Seating in which the permanent tendons will not be in place during concreting shall have a temporary tendon inserted or a small be stiffened by some other method to the approvals of the engineer. The temporary tendon shall be pulled out by a special threading machine or other contrivance before threading the permanent tendon. Where possible, tendons shall be placed prior to stressing. Tendons shall be handled with care to avoid damage or contamination to either the tendon or the sheathing. Any tendons which are damaged or contaminated shall be cleaned or replaced. Pre-tensioning, pre-stressing steel shall be accurately located and maintained in position both vertically and horizontally as per drawings. Encouraging device shall be set square to the line of action of the corresponding pre-stressing tendon and shall be positioned securely to prevent movement during concreting. The encouraging device shall be cleaned to the satisfaction of the engineer prior to the placing of concrete. After concreting, any mortar or concrete which adheres to bearing or bending surface shall be removed immediately. Cutting and trimming of wires or strands shall be done by suitable mechanical or flame cutters. When a flame cutter is used, care shall be taken to ensure that the flame does not come in contact with other stressed steel. The flame cutting of a wire restraint shall be carried out at least 75 mm beyond the point where the tendons will be gripped by the anchorages or jacks. In post-tension members, the end of pre-stressing steel projecting beyond the anchorages shall be cut after the grout has set. Protection of pre-stressing steel. Pre-stressing steel shall be continuously protected against corrosion until grouted. The corrosion protected shall have no deleterious effect on the steel or concrete or on the bond strength of steel to concrete. Grouting shall conform to these specifications or as directed by the engineer. In the case of external pre-stressing steel shall be enhanced in suitable polyethylene pipes before grouting. Seating duct joints. General. The seating and all joints shall be watertight and shall withstand a pressure of 1.1 times the grouting pressure and maximum grouting head due to grout. Any temporary opening in the seating shall be satisfactorily plugged and all joints between seating and any other part of the pre-stitching system shall be effectively sealed to prevent entry or mortar dust, water or other deleterious matter. Seating shall be neatly fitted to at joints without internal projection or reduction of diameter in large portion of the seating at coupling or anchorages shall be sufficiently length to provide for the extension of the tendons. Special attention shall be paid to the junction at the anchorage end where the seating must be tightly fitted on the protruding trump end of anchorages and thereafter sealed preferably with tape to make it waterproof. The joints between the end of coupler and duct shall be sealed with tape to prevent penetration of slurry during concreting. The coupler of adjacent duct shall be staggered whenever practicable. As far as possible, couplers should not be located in curved zones. The corrugated sleeve couplers can be conveniently manufactured using the sheathing making machine with the next higher size of die set. For typical detail of coupling, refer Appendix 1800. The coupling of HDP sheathing duct. The HDP sheathing can be joined by any of the following three methods: use of threaded sleeve coupler in the same manner as given for the metallic sheathing, welding of two ends of HDP sheathing using appropriate machine such as a roaster machine. Use of heat shrink couplers made of HDP sleeve. The sleeves are integrated with the parent sheathing by hot process by using heating torch. For typical detail of coupling, refer 1800 by 1. Encourages all bearing surface of the anchorages shall be cleaned prior to concreting and tensioning. Anchor cone, block and plate shall be securely positioned and maintained during concreting such that the center line of the duct passes axially through the anchorage assembly. The anchorage shall be recessed from the concrete surface by minimum of 100 mm. After the pre-stitching operations are completed and pre-stitching wire strands are cut, the surface shall be painted with two coats of epoxy of suitable formulation having a dry film thickness of 80 micron per coat. An entire recess shall be filled with a concrete or non-shrink pre-packed mortar of epoxy concrete. Suspension, pre-stitching operation and grouting shall be entrusted only to specially trained and qualified personnel. All pre-stitching accessories shall be procured from authorized manufacturers with in-house testing facility. The contractor shall be required to engage a specialized agency who should also be entrusted with the total service contract of for fabrication of cables, protection of cables during concreting, stitching and grouting. Necessary certificates shall be accorded by such a specialized agency that the work has been carried out in accordance with the prescribed specifications. In exceptional case, the pressure stitching and grouting operations could be entrusted to the bridge contractor himself if the employer is convinced that he is well experienced and has qualified personnel and sufficient track record to substantiate his performance in the particular system of stitching being adopted. Tensioning equipment. All tensioning equipment shall be procured from authorized manufacturers only and he in approved by the engineer. Grouting of pre-stitched tendon. Grouting of pre-stitched tendon shall be carried out in accordance with provisions given in Appendix 1800/3. A record of grouting operations shall be maintained in the format given in Appendix 1800/4. Pre-tensioning. General. The planning and construction aspects of the tensioning bed, tensioning bench, abutments at locations of anchorages, steam curing system, form of the concrete elements and arrangements for demolding, lifting, stacking and transportation of the pre-tension concrete elements are all specialized items of work and shall be entrusted to engineers especially experienced in this type of work. Concrete mix requirement. Minimum cement content, maximum water cement ratio and other durability requirements shall be same as indicated in table 1700-2 and table 1700-3 of these specifications, except that minimum grade of concrete shall be M40. Formwork. All sides, bottoms and headers form shall be of steel or any other suitable material. Forms shall be of sufficient thickness with adequate external bracing and shall be stiffened and adequately encouraged to withstand the force due to placement and vibration of concrete. All joints of home work shall be leak-proof. The bottom shutter shall have arrangement to permit a longitudinal movement of girder concrete which occur while imparting pre-stress. Identifying marks shall be placed on the girders to indicate the correct orientation to ensure correct debonding location which may not be symmetrical. Longitudinally laying of deflected tendons for long span pre-tensioned girders. Deflect tendons shall be used instead of the conventional straight tendons. These require the use of hold down device at each deflect location in order to hold the tendons in the desired profile and location. A hold down device normally consists of a roller attached to a vertical rod which passes through the bottom from and is anchored to the foam substructure or foundations to resist the pre-stress force. The force which must be resisted by the hold down device and therefore its size depends on the number of deflected strands and the trajectory angles of the strands. The strand can be either tensioned after it is held in its deflected profile by means of hold down device, or it can be tensioned first and then brought into the deflected profile. The number of deflected strands and their angle directly influence the size and cost of the hold down devices. Production and testing of concrete. A fully automated computer controlled batching plant shall be used. The batching plant shall be provided with minimum measuring and compensating device and automatic pump for dispensing admixture. Sampling and testing of concrete shall be as per section 1700 of this specification. Additional cubes shall be prepared to determine the concrete strength at the time of removal of foam and transfer of pre-stress. Adequate number of samples shall be taken up for this purpose, which shall be cured in identical condition to those of the concrete of respective girders. Compaction, removal of formwork and curing. Compaction of concrete shall be achieved through needle vibrator or foam vibrator along with needle vibrator for casting of precast beams. Any of the two commonly known techniques of precasting, that is long line method or short line method, may be used. The girder shall not be moved from the casting location until a stipulated strength requirement have been attained. The concrete shall have attained a minimum compressive strength of 20 MPa at the time of removal of foams. Curing of concrete may be achieved through water or steam followed by water curing. Approved curing compound may also be used. Longitudinal movement of the girders that takes place while releasing the pre-stress shall be suitably catered for in case of long line method of precasting. Adequate longitudinal gaps shall be provided between girder ends during precasting to accommodate a projection reinforcement and required length of the projecting strands. Stress band for pre-tensioning. The abutment and bed for pre-tensioning of tendons shall be designed to withstand the total tensioning force. A notice shall be displayed adjacent to the stressing bed showing the maximum tensioning force permitted where a concrete elements are cast and pre-stressed individual. The stressing bench or molds shall be rigid enough to sustain the reaction of the pre-stressing force without distortion. In the long line method of pre-stressing, sufficient locator plates should be disturbed throughout the length of the bed to ensure that the wires are maintained in their proper position during completing. The mold shall be free to slide in the direction of their length and thus permit the transfer of the pre-stressing force to all the concrete elements along the whole line. Sufficient space shall be left in between the ends of concrete elements to permit access for cutting the strands wires after transfer. Hold down or deflector shall be used for holding. Directing the tendon in required position firmly. Deflectors which are in contact with the tendons shall have a diameter not less than the tendon or 15 mm. Whichever is more, the tensioning force required to be applied as stated on the drawing shall be the force remaining in the strands wires. After all strands wires have been anchored to the abutments of the stressing bed and after the anchorage slip has already taken place, the tensioning force shall be determined by direct regarding of the pressure gauge or dynamometers and by the measured elongation after slip. The contractor shall submit method of tensioning the tendons including the alignments and layout of pre-tensioning beds and all tendons deflection points to the engineer for approval before manufacture commence. The contractor shall carry out trial stress operation to establish the frictional resistance offered by the hold down and slip during anchoring. The debonding of strands wherever required shall be carried out using HDPE debonding tubes. PVC tubes shall not be permitted for this purpose after pre-tensioning the strands and before concreting. A recheck shall be made to ensure that the debonding tubes are placed at the intended location, both end or the ends of the bonding tubes shall be effectively sealed against ingress of any cement slurry using epoxy putty or any other suitable material. The contractors shall also submit calculations showing that the hold-on have been designed and constructed to withstand concentrated loads resulting from the application of the tensioning force. Pre-tensioning and detensioning operation. Pre-tensioning of strands. Pre-tensioning of strands may be carried out either using single pull jack or multi-pull jack. In case of the former, it shall be ensured at the stage that the strands are stretched symmetrically so that the supporting system of the strands does not rotate or distort. This may be achieved through suitably designed moving trolley, engaging the strands or any other suitable arrangement. Pre-stressing force shall be transferred to metallic spacer trolley etc. so that the force does not remain on the hydraulic system for long. It is necessary to apply a small pre-stressing force through hydraulic jack to remove slackness of the strands. After removal of the slackness, the strands must be thoroughly examined to ensure correct alignment, including that of the debonding tubes. It is necessary to apply a small references marked for measuring elongation shall then be established and the pull strand load is applied thereafter. Load indicated by the gauging system shall control the tensioning with elongation checked on their strands. A small then we ensure that the entire load is applied. It shall be ensured that the entire length of each strand between the grips is free of any defects. This is of particular importance while precasting girders using long line method in a we ensure that the entire length of each strand between the grips is free of any defect. Transfer of the stress shall not proceed until the engineer has approved the proposed method. Strands and deflection device shall be released in such a predetermined order that proceed until the engineer has approved tensile stress are not and deflection device shall be in the concrete. Here to transfer of the force a predetermined to the unit, all strands shall be tested for tightness and any loose strands shall be reported to the engineer who will decide whether the affected unit should be rejected. The engineer may require that strands be marked at each end of any unit to allow measurement of the pull-in of the strands. The sequence of transfer of pre-stressing force shall be done strictly as indicated in the drawing and ensuring that eccentricities of the pre-stressing force in the vertical and horizontal direction of the concrete elements are minimum. During the entire sequence, the maximum slip of any tendon during transfer shall not exceed 3 mm for bottom strand and 5.5 mm for a top strand at any end of the concrete element. In case the slip exceed above value, design of the member shall be got checked for the actual slip before acceptance. Detensioning of strands. Detensioning in order to In part, the pre-stress shall be effected gradually so that there is no significant loss of bonds due to slippage of strands and consequent increase in the transmission length. For detensioning, the trolley is pulled outwards by a small distance in order to release the metallic spacer before releasing the pre-stressing force. Even when the pre-tensioning is carried out through a single pull jack, the release of the force in all the strands while imparting the pre-stress to the concrete shall be simultaneous. It shall be ensured that during this the process pre-stressing force at any stage does not exceed 90% of 0.1% proof stress. Cutting of strands shall be carried out carefully so as not to affect the untensile reinforcement which is in their close proximity. Diamond bit saw shall be used to cut the strands and untensioned reinforcement shall be so arranged that the untensioned reinforcement and those strands which are required to be extended into the adjoining cast in situ concrete do not get affected during cutting operation. Under factory conditions, flame cutting may be restored to yellow flame should be used first off to heat the strand without introducing a undue stress, and then blue flame for the actual cutting. Heating of strands shall be carried out symmetrically about the vertical axis of the members, one strand at a time on each side of the vertical axis. For all girders in a long line shall be cut in the same manner. The above process shall be repeated till all the strands are cut. This will ensure gradual and uniform transfer of pre-stress to girders. Protection of ends. The exposed end of the strands and the concrete surface of the end of the units shall be wire brushed clean of all rust, loose mortar, grease, and dirt. The exposed end of the stands and concrete surface within 50 mm of tendons shall be then abraded to provide a clean sound surface. An epoxy tar paint suitably formulated to give a dry film thickness of 80 micron per coat shall then be immediately applied over the end of the tendons unless otherwise directed. A second coat of paint shall be applied prior to the drying out of the first coat. Safety precautions during tensioning. Care shall be taken during tensioning to ensure the safety of all persons in the vicinity. Jacks shall be secured in such a manner that they will remain in position even if their grips on the stand is lost. No person shall be allowed to stand behind the jacks or close to the line of the tendon while tensioning is in progress. The operation of the jacks and measurement of the elongation shall be carried out in such a manner that The safety of all concerned is ensured. A safety barrier shall be provided at both ends to prevent any tendons which might become loose and recoiling unchecked. During actual tensioning operation, warning signs shall be displayed at both ends of the tendon. After pre-stressing, concrete shall not be drilled out, chipped or disturbed in any way without express approval of the engineer. No welding shall be permitted on or near stands, nor shall any heat of the applied to tendons. Any strands which has been affected by welding or weld spatter or heat shall be rejected. Surface preparation. All surface coming in contact with deck slab diaphragm shall be adequately prepared by green cutting using surface retarder by mechanical means to remove the latents and storage and holding of precast girders. Precast girders shall be transported in a upright position. Points of support and the direction of the reaction with respect to the girder shall approximately be the same during transportation and storage as when the girder is placed in final position. Method of transportation should be planned in such a way that the vehicle employed to transport the long girders can successfully negotiate the available road geometry. Adequate care shall be taken to ensure that the girder being transported does not topple due to unstable arrangement. For this purpose, height of the vehicle shall be kept as low as possible. This will also help in accommodating greater height of the system during transportation below existing bridges or through any other constraints. Girders should be transported only after 28 days concrete land. Of a precast girder to prevent lateral movement or instability. Care shall be taken during storage, hoisting, and handling of precast unit to prevent them from being cracked or damaged. Units cracked or damaged by improper storing or handling shall be replaced by the contractor at his cost. material shall be tested in accordance with the specifications and shall meet the prescribed criteria and requirements. The work shall conform to those specifications and shall meet the prescribed strengths of acceptance. Measurement for payment. A stressed concrete shall be measured in cubic meter volume occupied by milled steel reinforcement HYSD bars, high tensile steel sheathing and anchorages shall not be deducted. High tensile pre-stressing steel shall be paid for separately. Its length as actually incorporated in the finished work shall be measured and weighed, calculated. Rate. The contract unit rate for cast in situ pre-stressed concrete shall cover the cost of all materials, labor, tools and plants required for mixing, placing in position, vibration and compacting, finishing as per direction of the engineer, curing and other incidental expenses for producing concrete of specified strength to complete the structure or its components as shown on the drawing and according to specification the contract. For precast pre-stressed concrete member, the unit rate in addition to above shall also include the cost of all materials, labor, tools and plants required manufacturing in cast bed, transporting and placing the members in their final position as shown on the drawing are as directed by the engineer. The contract unit rate for high tensile steel shall cover the cost of the material, labor, tools and plants required for producing, placing, tensioning. The contract unit rate for high tensile steel shall cover the cost of material, labor, tools, and plants required for producing, placing, tensioning, anchoring, and grouting the high tensile steel in the pre-stressed concrete as shown on the drawing and order specification or as directed by the engineer. The cost of anchorage device, additional length of cables for effecting jack ducts or sheathing grout of non-pre-stressed steel reinforcement first to the anchorage. The cost of the anchorage device, additional length of cable for attaching jack ducts or sheathing grout, non-pre-stressed steel reinforcement fixed to the anchorage device, making of a recess and filling the same, protection of by painting with epoxy and Furnishing samples for testing shall all include in the unit rate. Rate shall also include payments if any of the made to be supplier of the PRESTRESSING system, who has to monitor, ensure, and certify the corresponding certify the correctness of all operations.